Audio test. Testing audio. What on YouTube? Okay, looks like it's okay. Hey, so I lost my voice because I got sick over the weekend. So I'm probably not gonna be talking as much, but I still just wanted to like run through a problem. Oh, there's questions and stuff, and I'll answer those, but I'm probably gonna be a little bit just kind of working here on myself. I put a note up, so hopefully people see it. I don't even know if that's readable in the corner. Okay. I'm gonna figure out which problem I want to do. Maximal rectangles, that's fun. Visual. And I have to least read the description. So given rows x columns or rows times columns in a binary matrix filled with 0 and 1s, find the largest rectangle containing ones and return its area. So I guess there's a rectangle over here on the left. There's a rectangle here. And if there's nothing, which is 0, and the matrix is 1 is 1. All right, conceptually, seems easy. Is there any constraints on speed? No. Okay. Well, draw it out. Then go like a rectangle here, and there's going to be tons of because there's also like 4 and 3 to those, but these are our candidates. Here, we would have found this one, this one. So we're going to find multiple rectangles inside this grid, and we need to find the one with the maximal area. Largest, meaning assuming area. So this one's 5, but this one's 6. I mean, the first thing that comes to mind is brute force. Just put that down. Which would be something like, start top left. Every rectangle is largest. So that might something like even that would be like check this one, and then I don't know which direction you want to go first, but and you try to go over, I guess, too. Um, but you wouldn't be able to. Like, because there's a question of you would go like on the back here, do we expand bottom or down? I don't think there's a right or wrong choice there. You can stand there. They try and see it can I expand right, and in order for you to do that, these both have to be on, which they're not. I think once you can't expand right, then you're pretty much like blocked. And then you'd also have to try and go right. In this case, there's nothing right. So it might be more interesting to look at what this would look like for when we get this block, because it's going to look something like first check here, then check here, then check here. And we try and go down and we can't. And we go right and we're good. If we were going the other direction, it would be this and try to expand out, then try to expand right, and then try to expand down and we can't. I feel like this is missing an edge case though, where like imagine if we were going the other direction, I guess. Imagine if we were starting here and we were, or actually maybe, yeah, actually this one's going right here. Because if we go right, um, you can't go down. And so eventually this one's gonna get this whole thing. But then we also need to check this direction. So there's a lot more squares down here. Maybe there's like another strip that goes way down. I'm just gonna draw a little bit of this to represent happening. Okay, just gonna shrink this down as brute force method. Should we see if we can do something a little better than brute force? I don't know if I'm thinking of anything. It feels like no matter what we do, we're gonna have to look through every single item to see the potential that's like our top left corner of our rectangle, the large rectangle. So we're gonna have to go through a pass and attempt to figure out if that's where we're at. There might be some efficiencies in like this edge case that I was talking about where it's like I have to go left and right. But I'm not seeing anything that jumps out. I think we're gonna handle the case where like we might get a rectangle that's really, really big. But then there could be like starting in a slightly different position, one that's even larger the other direction, right? Um, so I'm honestly not seeing anything better than this. Could be I'm like a little under the weather, so my brain power might be at high efficiency, but I feel like that's what you gotta do. You gotta just go through each corner essentially, figure out what the biggest rectangle you can make from this corner, and then um, move to the next potential corner. So I guess let's write that out as a code uh, for each. Okay, one of them. I guess there'd be two rectangles. Yeah, there could be like we might have a case where we've got a rectangle that goes this way and a rectangle that goes this way. You can just do it twice, once the one direction, once the other direction. But uh, the way that I described the algorithm is no problem too, because this could be something like this, right? Um, where we go one direction and then we go, oh, we can expand this direction. And then we think, oh, we can't expand anymore, so we're done. But actually, if we'd like stayed going down one of the other places, um, we would have a larger spot. And then also, um, we might want to do something about not rechecking things. So, for example, uh, this square right here, if we check it later, that's kind of redundant, right? Like if we make this a little bigger, like we're wasting time checking this corner, I think. Well, maybe not though, because maybe there's like a little channel here that we couldn't start from this corner. But if we go down that channel, it works. We can't even necessarily do that. So it almost feels like we're gonna go all the way one direction, see as far as we can go, and then we have to go. Well, what if we went two squares and as far as we can go, and then three squares as far as we can go? So then we really are brute forcing because we're really trying every single possible size triangle. I mean, it feels like this is like very slow. Like it's just very brute force. And it feels like there's probably a smarter way to do this. But nothing's popping off the page for me. So, okay, find the maximum work. Let's really check all possible I check these possible with or just um, there we only there. Yeah, that's it. So for the starting x equals 0, starting x is then it's the length is actually x's is your y's technically. It doesn't actually matter. Or let start x equals 0. X is the probably keep track of what our width and height is. Width equals x 0. We can always assume there's a the length is rows and columns are both between 1 and 200, so you should always be able to do x and that. A little better. So if then width x, get us to go through each possible corner, and then for each possible rectangle inside of that thing, for left and y equal starting y and y is less than height direct. And x equals start x. X width and x. So this loops is going to give us if position that we're trying to look at. We also have to look again for validation. If we're trying to add an x, we got to look through all the possible heights to see if they're all valid. Or let's check y equals start y, and then we'll check y is less than or equal to end y, check y plus plus. So for each possible height, for each possible width, check all new column boxes. So false. Do the thing afterwards. It's valid. Sure, we have proof that it's not valid. So we're gonna say it is valid. We'll prove it false. But then what we need to do is if matrix R and X, basically the X that we're trying to include, that's what configured to me. I'm just gonna be Y's first. So if I check Y and X equals 1, equals 0, then we want to it is valid equals false, and we want to break. And then only if it's already not valid, then we can just break as well. So we don't need to keep checking more X's because this one failed, so we're not going to be able to keep adding X's anyways. Otherwise, I guess we don't have to do this. A little bit inefficient. Well, I'm just going to give it for convenience. I'm going to do my. We could wait until we get to the end. And the maximal one that we got is the one to use. But I'm just going to keep it updating it here. Updating the maximum. What max area? Area. Yeah. Here's where I'm going to do that. It's in max area. Max of max area and whatever this area is, which is start x and x minus start x, which technically it's going to be one more than that because when they're at the same location, start x, start y might be the same index over here. Right? All the same x's. But that width is 1. So times let's see what happens. Fully check with this. Cannot. Oh, I just misspelled matrix. For me. These are strings. Okay, sorry. Oh, it shows me down here, 3 strings. Yeah, well, we passed all our cases. Let's try submitting. I'm gonna guess if it passes, it's gonna be super slow compared to other people. Time but exceeded. Oh, well, there's the case where I was talking about where you might not want to check the same thing again. Okay. Um, there's a lot of inefficiency with this particular case, right? Because we pull this out over here, right? What that example was the whole grid is gonna be it's really big, 200 by whatever, and like I'm got a loop inside of a loop inside of a loop. Um, so we're taking a long time, even just for the first one, to like go down here and then check all these, and then check all these, and then check all these, check all these. We go through the whole thing, and then like we go one over, and we gotta do the same thing for all of this, and then again we do the whole thing for this, whole thing for this. And when we get all done with that, we do it here. Can we do it here? And so it's just like it's a lot of repeated checking, and a lot of overlap. Um, is there a way that we can avoid that? The thing we can't do is just say that, well, we already checked this square, so it doesn't need to be checked because I don't know if this is obvious what's going on here, but um, imagine if got like a grid this and got here too. You might have a channel that exists down here. That's what I'm trying to map on here is like we might, well, we might have already checked this spot right here, but just because we checked this pink, where this pink one's starting, there might be some channel down here that exists that's got blue squares that we want to keep. So we can't not check it. We could cache. New plan. Take one of those again below. I'll go do this. I'm gonna label these. It's just I think this is trying to demonstrate the same thing as this thing, so that one's well, maybe make it smaller. So, but my next idea is, what if we do something where we first count the like in one direction. So we do something like where not sure this, comma or should make this black. This one's 1, 3. Um, and we're just going like we're basically going in like we're checking the X and we're checking the Y, but we're just maximally 5 and 2. Like this is telling you how far you can go this direction for this square, and this is telling you how far you can go that direction. I don't know if this is going to be useful or not. I'm just, we get ideas sparked in our heads, and then we like try them out. Um, this is going to be 1, 3. This one's going to be 3 and 2. Maybe 3 and 1. This is going to be 4 and 1. That makes sense. What I'm trying to, like, is a potential like pre-pass to like figure these things out. 3 and 2. Go 2 over and 3 down. I don't know. Again, I don't know if this helps me. It's like 2 and 2. And 1 and 2. I think these are just 1 and 1. Like if we had this information first, would this help us accomplish our tasks better? Um, because then basically we'd be, I guess what I'm trying to think is, ideally what we do is we'd find like, actually maybe that's even a different way of thinking about it than I was just thinking about it. But what if instead of like looking for every possible rectangle, we try grouping rectangles. Right, I'm gonna put this idea all the way to the side for just a second. Different idea. Um, how to curly? Just like this. If I want a second one, is it? Turn over to wishing I had to like add another control point. I feel like if I put a shifter, yeah, control enter, control a double click or press control enter data points. Yeah, so like, how do I add a new point? Shift 7 to alt to click. This is we decided. Maybe arrows only help 2 control points. Well, anyway, I guess it's actually a problem. I can zoom out this one. Yeah, okay. All right, fine. That's enough. Okay. So if we playing too much with this. Okay. So new thought. Um, my new thought is treat them as blobs, and we like are combining blobs together. So we'd start with each of these, and then we would check to see if we can combine a blob together and make it bigger. Well, but actually, okay, now that I spent all this time, it's gonna have the same problem. Um, like my thought was, okay, like we can go, oh well, we can join these two together. We can make blob. Um, but the problem is this one, same problem down here, which is that if I join these like shared blobs into one, there might be two overlapping rectangles that won't work. Okay. Going back to the thing for just a second. Side diversion. Okay. Does this help me at all? Because if I could just look at my neighbors and know how far they can go, I'd be able to early out quicker. Because like if I'm like looking at this one, I can look at my neighbor and go, well, you can't go down anymore, so you're not helpful, right? Like if I've got this 3-2, I can go here and go three. I know I'm 3-2. Um, I just can go down the line and see how many threes I have. Because three's going to be the maximum, and then I can go here and see how many twos I have, or something that's greater than 2. So I only need to scan if I've done the pre-path to get this information. Then I only need to. I don't need to like go down each of these channels again. And it feels like calculating this might be a little bit faster. Um, okay, let's like just label this out. I don't know if I have time to implement this today. Do some things with it today, but at least let's like write it out. We can take it up next time. The idea would be like pre-pass, check max x, max width, I guess, really, or max width, assuming height 1 for each square. assuming with 1. And then check each possible corner. Only. Yeah, but still an interesting problem. I'm like wondering because if we got a long square here, but a bigger rectangle here, there's gonna be more area, right? But I think that's okay because you can still. I think if we start here, we're like we'll go max 2. The best we can do is 2 by 1, 2 by 2. Because even though this is 3, we can't go. If this is 2, it's the minimal of what we've seen so far. If we assume there was like one more over here, right? Right. I think we just check the areas because we're gonna go the maximum area for this. Well, for this square right here, we know that we could go down 2. Right, we're gonna have to check both directions. Right, so we'll go down 2, assuming the width was 1. So that's area 2. And then we're gonna say, oh, this one goes down 3. You can only go down 2 on this one. So 2 by 2 is 4. And then we're gonna go with this one. Still, the maximum we go down is 2. So 2 by 3 is 6. And then we're gonna go this one. And we're gonna go, oh, well, the maximum we can go is 1 by 4, which is less than this. So we'll just give up. I mean, this feels somewhat promising. About 4 minutes. I don't know if I can implement it in 4 minutes. uh, but let's give it a shot. No, I'm going to implement this. I don't know why. Basically, consider these my x and these my y. It was like x0, x1, x2. I know it feels weird, but indexing, not indexing down here, it's like hurts me. I don't know why. Uh, with height. So I'm running out of time. I'm just gonna speed run this. Okay. Hopefully we can do this in one path. Um, Three paths. 2 minutes. I don't think I would get it. Let's see if we can at least get the pre-pass done. Let previous y. You can keep track of the last like solid. Solid what we saw. To do this in both directions. Save. I'll do flex first. Just feels better to me. Doing this, even though I drew it this way, I think I'm gonna do it in the reverse. So the would be like 4, 3, 2, 1 because keeping track the other direction. I don't need to go back and fix anything. I'm not like looking forward. I already have searched. I've searched back here. So once I get to here, if I haven't had anything block me, I know what the width is, and I can just record it then and there. Also, we also need our own uh, okay, I gotta go do some stuff, so I can't quite get through. I don't even know if anybody's watching. I'll come back to it next stream. Hopefully, I remember what my plan was. Have a good one.